Let's discuss quantum computing. Before we talk about what is quantum computing, let's discuss about what is classical computing. Computing is having binary foundation. It uses the bits 0 and 1, which is the smallest unit of data, forming the foundation of all digital information. Also, it operates with transistors switching on and off to perform logical operations at very high speed. It powers all current computers, smartphones, and servers worldwide. And here, the processing of the information will be done in a sequential manner. Now, let's see what is quantum computing. Quantum computing is a revolutionary computing method which uses quantum mechanical phenomenon like superposition and entanglement to process information with qubits. Qubits are the fundamental entities or basic building blocks of quantum computing, which could be 0, 1, or both simultaneously through a phenomenon called as superposition. Uh, these phenomenon allows qubits to work simultaneously, enabling massive parallel calculations for problems impossible for classical computers, and which is having potential applications in medicine, AI, finance, and cryptography. Quantum phenomenon, as I mentioned here, are like quantum entanglement and superposition. Quantum entanglement is used to link qubits across distances instantly, creating unpredicted computational connections. Then it is having extreme conditions, requires near absolute zero temperature to maintain qubit stability and prevent environmental interface. Here, this is as it is an emerging technology. It is at its early development, but promises exponential speedups for certain complex computational problems and having huge applications in medicines, AI, finance, and cryptography. Qubits, which are the basic building blocks of the quantum computer, works on quantum mechanical phenomena such as superposition and entanglement. Superposition means we may say qubits represent multiple states at once, and that's why they can have parallel computation simultaneously, which increases the speed of processing. Next, they are having the entanglement principle, in which qubits become interconnected to the state of one instantly influence other, regardless of physical distance, and that's why the multiple computations are possible with no time. They works with exponential power. An 8 qubit quantum computer can represent 2 to the power 8 is equal to 256 states simultaneously, which is not possible in case of classical computers, and therefore there will be huge amount of processing with high speed. Quantum computers are having various kinds of practical applications. One is complex optimization. It enables solving intricate optimization problems in logistics, finance, and artificial intelligence that involve millions of variables and constraints. Then they are having the applications in the area of molecular simulation, simulating molecular and chemical interactions for drug discovery and material science, and accelerating pharmaceutical research is possible with the help of quantum computing. They can be used for cryptographic analysis, in which breaking certain cryptographic codes that classical computers cannot crack efficiently, which revolutionizes the cybersecurity. Then they are having the applications in the machine learning, Quantum computers enhances machine learning algorithms with faster data pattern recognition and more sophisticated AI model training. So various areas are there where you can see the quantum computer excels. Besides the huge practical applications, quantum computing faces certain kinds of challenges right now. One of the challenges is nothing but qubit fragility. Qubits are extremely fragile and prone to errors from heat, vibration, and electromagnetic interference, which requires constant protection. Then, quantum computers are costly and complex. That's why it limits the widespread use. Currently, they are used only in the research institutions and major technology companies. Quantum computer requires sophisticated error correction and isolation technologies to maintain quantum coherence and computational accuracy. Classical computers remain more practical as compared to quantum computers for everyday tasks and general computing needs, from document editing to web browsing. The processes are simple in classical computers as compared to quantum computers. So these are certain kinds of challenges quantum computer faces today. It has been seen that classical computers remain efficient, reliable, and accessible for most of the everyday tasks and general purpose applications, whereas quantum computers will serve as specialized accelerators for problems where the classical computer struggles. So, it has been seen that combining classical and quantum processes are the emerging future, and therefore we can say that the future belongs to hybrid architecture where classical computers handle routine operations while the quantum computer processes specific computational challenges requires the unique capabilities. To have more focus on quantum computing on a global level and in India, certain initiatives are taken. India investing in quantum research through government initiatives like National Quantum Mission and emerging quantum technology startups. Global tech giants like IBM, Google, and Microsoft racing to build scalable quantum machines and cloud-based quantum platforms. Quantum computing industry projected to reach near about $1.3 trillion by 2035, creating new opportunities worldwide. Preparing IT leaders and businesses now is key to leverage the quantum advantages tomorrow and staying competitive. So these are certain kinds of initiatives for quantum computing on a global market as well as in India. So in summary, we can say that classical and quantum computing operate on distinct principles but complement each other perfectly. Quantum computing promises breakthroughs in science, security, healthcare, and technology. Understanding these differences today prepares us for the transformative impact ahead. So, the quantum era is approaching. Are you ready to explore the possibilities?